What if, in one of the shortest moments of the human body, control is quietly taken away from the brain and handed to something far deeper, faster, and impossible to stop? Deep inside the male body, a silent sequence begins, almost invisible, almost instantaneous, yet unfolding with extraordinary precision, as if dozens of hidden mechanisms had been waiting for this exact signal. Muscles preparing, glands primed, nerves already carrying instructions faster than conscious thought. And although it lasts only a few seconds, what happens in that brief window is anything but simple. But this is only the surface of what is really happening. Most people imagine ejaculation as quick, automatic, over before it can even be observed. Yet beneath the surface, a complex orchestration unfolds, more than 30 structures activating in exact timing, each one dependent on the other. The bladder temporarily shifting its role, valves sealing pathways, pressure building silently like a chamber approaching release, and at the center of it all, a system designed not for awareness, but for precision. And that's where the first real surprise begins. At the peak of this process, the conscious brain is no longer leading. A deeper reflex embedded within the spinal cord takes control, executing a sequence that no conscious effort can interrupt, raising a fundamental question. Why would such a brief event demand such complexity, and why does the body reorganize itself so completely for just a few seconds? But the answer starts much earlier, in a system hidden in plain sight. To understand this, everything begins with the anatomical network behind it, where sperm are produced inside the testes, small but highly specialized structures protected within the scrotum. Each cell forming through a precise biological process before moving into the epididymis, a tightly coiled structure where they mature, gaining the ability to swim, becoming capable of movement in a microscopic world invisible to the naked eye. And once ready, they enter long muscular tubes known as the vas deferens, not passive channels, but active pathways lined with smooth muscle, capable of pushing their contents forward with rhythmic force. But sperm alone are not enough. Behind the bladder, the seminal vesicles contribute a fluid rich in fructose, a source of energy essential for movement, while the prostate gland releases enzymes and an alkaline fluid designed to protect and stabilize, creating an environment where survival becomes possible even under hostile conditions. And all of these elements converge into a single pathway, the urethra, a channel normally reserved for urine, now preparing to serve an entirely different function. And this is where the system reveals its true complexity. Because under normal conditions, the urethra belongs to the urinary system, and for ejaculation to occur, the body must temporarily switch modes. A circular muscle at the base of the bladder, the internal urethral sphincter, contracts tightly, sealing the bladder and preventing any backward flow, ensuring that everything moves in one direction, only outward. A protective mechanism so precise that even a slight failure would disrupt the entire process. But this transformation does not happen randomly. It is controlled by the autonomic nervous system, specifically the sympathetic division, the same system activated during moments of urgency and intensity, coordinating multiple organs at once, preparing the body for action. And yet, ejaculation itself is not a single event. It unfolds in two distinct phases, each one triggered with exact timing, each one dependent on signals traveling through the spinal cord. And the first phase begins before most people even realize it has started. The first phase is emission, where smooth muscles along the vas deferens begin to contract, pushing sperm forward toward the prostate, while at the same time the seminal vesicles and prostate release their fluids, merging together within the prostatic urethra to form semen, pressure gradually building, not explosively, but steadily, as if the body is preparing for a controlled release. And as this pressure increases, stretch receptors within the urethra begin to detect the change, sending signals back toward the spinal cord. And this is where everything shifts. Once a critical threshold is reached, a reflex is triggered, not by conscious decision, but by a signal loop within the spinal cord itself, initiating the second phase, expulsion, where the process transitions from preparation to release, and unlike emission, this phase depends on skeletal muscles, particularly the bulbospongiosus muscle in the pelvic floor, which begins to contract rhythmically, approximately every 0.8 seconds, each contraction pushing semen forward in distinct bursts, creating a pattern that is both mechanical and precise. While at the same time the bladder remains sealed, the external urethral sphincter relaxes and the urethra slightly shortens, increasing both pressure and velocity. But the most striking detail is still unfolding. Because once this reflex is activated, control is no longer voluntary, the spinal cord executes the sequence automatically, and while the brain still perceives the experience, its role in control diminishes, explaining why the sensation feels involuntary, not as a loss of function, but as the activation of a deeply embedded biological program designed for reliability, ensuring that once initiated, the process completes without interruption. And yet the body is not finished. At the moment of climax, the entire system is in a heightened state, the sympathetic nervous system fully active, heart rate elevated, muscles tense, signals firing rapidly across neural pathways, but almost immediately after release, a dramatic reversal begins. The parasympathetic system takes over, shifting the body from activation to recovery. Heart rate slows, breathing deepens, muscle tension fades, and within the brain, chemical signals begin to change. Dopamine briefly peaks and then declines. Oxytocin increases, promoting relaxation, and prolactin rises, marking completion and initiating what is known as the refractory period. And this transition happens faster than most people realize. During the refractory period, the body temporarily prevents another ejaculation, a recovery phase that varies between individuals and tends to lengthen with age. While internally, systems begin to reset, the bladder neck gradually reopens, pelvic muscles relax, the prostate reduces its activity, and any remaining semen clears from the urethra, restoring the system to its baseline state, completing a cycle that, from the outside, appears to last only a moment. But inside, it was a coordinated sequence across multiple systems. Muscular, neurological, hormonal, and vascular systems all participate in perfect synchronization, each phase dependent on the next, each signal timed with precision, creating a process that is both efficient and protective, safeguarding sperm, preventing backward flow, ensuring directional movement, and maintaining internal balance before, during, and after the event. But the deeper realization goes beyond the mechanics. Because what appears simple on the surface is supported by layers of coordination beneath it, a reminder that the body often performs its most complex work silently, without awareness, without interruption, transforming a brief moment into a demonstration of biological precision where reflex and regulation coexist, where instinct overrides conscious control, and where systems built over millions of years operate flawlessly in just a few seconds. And that leads to the final realization. Ejaculation is not just a release, it is communication between glands, nerves, muscles, and hormones, a sequence that begins quietly, builds with precision, and resolves with a complete physiological reset, revealing that even the shortest events in human biology can involve extraordinary complexity, and that behind what feels instantaneous lies a choreography so refined, so controlled, and so efficient that the body completes it without hesitation, without error, and without the need for conscious command. And once you see it this way, it becomes impossible to ever call it simple again.